Welcome to our video lesson all about similar triangles. Now this is a topic that I find really fun because I think they're all like little puzzles that we have to figure out. So let's get started. Before we can talk about how to use similar triangles, we need to talk about how to name them and how they're written. The first thing you'll see when you have two triangles that are similar is you'll see it written this way. So triangle SAT, then you'll see this little wavy sign, and that means is similar to. So this means triangle SAT is similar to triangle FIG. The way I've named these is very important. I wrote S first in both triangles, and that's because S and F are corresponding vertices. They are matching angles, so this angle value, whatever it is, oh, that's really big. This angle value, oh, that's not what I wanted to do. The angle value of F and S is the same. So that's why we have to write triangle SAT is similar to triangle FIG. The next thing we can tell about the way we've named it is that the vertices A and I must be the same as well. So these angles, A and I, must be the same. And the last thing we know is that angles T and G also must be congruent or the same. So when you're using triangles, pay close attention to how they're named, and that will help you with your task, whatever it is you're going to do with them. The next thing is proving triangles. So a question might ask you to prove that two triangles are similar. Now you've done lots of things to explore this. However, to actually prove that two triangles are equal, there's two things you can do. First of all, you can prove that their sides are proportional, or you can prove that all their angles are the same. Now in this situation, we don't have any angle values, so we can't prove that their angles are the same. However, we do have all the side lengths, so we can prove that the sides are proportional. Let's start with side SA and side FI. SA, the side here, and FI. To write it out, I'm going to write it as a fraction. So side SA over side FI is equal to the value of SA, which is 8, over FI, which is 3.2. And they're both in centimeters, so I'll just have that centimeters there. And then I'm going to simplify this into a fraction. And that would give me 5/2. All right, let's do our next side. Our next side here will be AT, which corresponds with IG. So I'm going to write that AT over IG is equal to 15 centimeters over 6 centimeters. And when I simplify that, you can divide both of them by 3. So we get 5, and divided by 3 is 2. So again, we have 5/2. Last side. So we have ST and FG. Now one thing to notice, I'm always putting the first triangle as the numerator and the second triangle as our denominator. So here I'll write side ST over side FG is equal to 17 centimeters over 6.8 centimeters, which should give us 5/2, but let's check it out. And it does. We get 5/2 again. Now because all their side ratios are proportional, and let me write that word here. It's a very an important word, proportional. Because they're all proportional to each other and they're all of the same proportion, therefore we know the triangle SAT must be similar to triangle FIG. This is how you write it out. All right, let's look at another example. Okay, we are going to do the exact same thing we did on the previous side, but in a little different way. So it says determine the unknown angles and side measures of these two triangles. Now it tells us at the top that triangle HIE is similar to triangle GFE. Now, especially when you're first starting out, one of the things I suggest is use colors, a nice highlighter, to help you figure out which angles they're talking about, so you can help figure out which angles and which sides are corresponding sides. So in this case, we have H here, so H will be right here. Then we have G, so let's use the same color because G and H we know are corresponding. Let's change up the color. I and F are corresponding, so that means I, oh, I wonder why it's not letting me do that. I and F are corresponding. And the last one, E and E, because E and E are the same angle, so it's corresponding. Alrighty, it says determine the unknown angles and side measures. Let's start with the angles because they're a little bit easier to do. Remember that when two triangles are similar, all the angles have the same value. So let's start with triangle HIE. We know that all the angles inside of triangle HIE have to add up to 180 degrees. And how I can write that is like this. Angle H plus angle I plus angle E all have to equal 180 degrees. I don't know the value of angle H, but I do know that the value of angle I is 75 degrees, and the value of angle E is 20 degrees. So that has to be equal to 180 degrees. Well, 75 plus 20 is going to give me 95, so angle H plus 95 degrees is equal to 180 degrees. Now I solve this side of my equation by subtracting 95 degrees from both sides, and I get that angle H is equal to 85 degrees. So that means that this angle right here is 85 degrees. It's really hard to see. Now, using my corresponding angles, I know that angle H has to be equivalent to angle G over here. So this must be 85 degrees. And the angle F has to be equivalent to angle I, so that means that this must be 75 degrees. And I know that angle E has to be equivalent on both sides, so this must be 20 degrees. So now I've solved the unknown angles, and now I need to do side measures. This is where it gets a little bit interesting. Now it's important that you write it correctly. Let's start with our known sides. There are two corresponding sides that we know both of. And that's this side right here, sides HI and side GF. So I'm going to write them as a proportion. HI over GF. And because all the side lengths in here have the same proportion, HI over GF has to be equivalent to HE over EG. So that would be this side here, HE over EG. What I do next is I substitute everything in. So my HI, this side here, is 8 meters. So I can write 8 meters here instead of HI. GF is 4 meters. HE is 10 meters. And we don't know the side of EG. Here we can use cross multiplication like we can with all proportions. So we know that 8, I'm not going to write the meters anymore, 8 times EG has to be equal to 10 times 4. And then I divide both sides by 8 to get rid of this 8 over here. So that means that EG must be equal to 10 times 4 divided by 8. 10 times 4 is 40. And 40 divided by 8 gives me 5. So that means that EG has to be equal to 5 meters. This is a very nice proportion. It works out using whole numbers, so it's pretty easy to do, and you might be able to do it in your head, but I need you to see how to do it mathematically. The only other side we're missing is this side here. EI and EF are corresponding sides. Let's start with the side we're missing. So let's do EI over EF has to be equal, again, to our HI over our GF. So EI is a side we don't know, so let's leave it as EI, but we know the value of EF, it's 7, and that's equal to HI, which is 8, over GF, which is 4. Now this becomes a lot easier, we just multiply both sides by 7, so EI is equal to 8 times 7 divided by 4, and 8 times 7 is 56. And 56 divided by 4 is 14. So now we have solved for all the unknown angles and side measures of this triangle. Let's do one more example of a different type of corresponding triangles. So we actually have two triangles written down here in this triangle mixture. The first one, I'm just going to label it for you to help you see it. The first one is triangle FGD. So that'd be F, G, and D. It is proportional to triangle ECD. Notice that again, I matched up my corresponding sides with angles. So that means that angle F and angle E are corresponding. Angle G and angle C are corresponding. You can actually see that they're both 90 degrees. And angle D and angle D are the same angle, so they're corresponding. So it says find the length of side CE and the missing angles. Well, side CE is this side right here. Let's start with side CE. Okay, this side length down here is 6 meters. And that is side GD. Now side CD is 3 meters. And we know that side FG is 8 meters, but we need EC. I'm going to write it as a proportion, starting with the side we need to solve for. So we need to solve for EC. And EC is proportional to FG, which has to be equal to the ratio between side EC is a small triangle, so it would be CD over GD. Now I'm going to substitute everything in. EC, I don't know, so I'm going to leave it. FG, I do know, is 8 meters. CD, I know, is 3 meters. And GD, I know, is 6 meters. Now EC is equal to 3 over 6, and then I multiply the 8 to get rid of the 8 down here. So I'm going to multiply both sides by 8, so 3 times 8 divided by 6. 3 times 8 is 24. 24 divided by 6 is 4. So that means that EC is 4 meters. Now we've solved for side CE, or EC. It's the same side, just put the letters in the opposite order. The next thing I need to do is find the missing angles. Well, let's start with triangle ECD. Again, I know that angle E plus angle C plus angle D has to be equal to 180 degrees. Well, angle E, I don't know what it is. Let's keep it as angle E. But I know the value of angle C, it's 90 degrees. And I know the value of angle D is 23 degrees. I don't know, sorry, my pen's having a hard time here. Let me start again. Angle E plus angle C plus angle D, it's not letting me write, equals 180. Oh no. Well, let me just do it down below. Angle E plus my C is 90 degrees, plus my value of D is 23 degrees, is equal to 180 degrees. I need you to imagine there's 180 degrees written right there. So that means angle E, 90 plus 23, is going to give me 113 degrees. And then I subtract 180 minus 113, and I get the angle E is equal to 67 degrees. So that means that this angle right here, angle E, is 67 degrees. So what that means is that angle F, because they're corresponding angles, and these are similar triangles, must also be 67 degrees. And now we have solved for all the missing angles in our triangles. This question is a little bit more challenging. It says, find the length of MA. These two triangles are similar triangles. You know because they have parallel sides, so that means that these angles must be equivalent to each other. And if these angles are equivalent, it means that this angle is the same, so it must be equivalent as well. All right, we need the length of side MA, which is this side right here, MA. We need to start with our corresponding side. So I'd write the MA, which is the side we want to find, over ST, because those are the corresponding sides, is equal to, MA is our big triangle here, so that means it would be MH over whatever our smaller triangle side is, so that would be HS or SH. And we don't know the value of MA, but we know the value of ST is 5 centimeters. MH, now MH is this whole distance here, which is actually equal to the value of 20 plus the value of 4, so it's 24 centimeters. So it'll be 24 over SH, which is 20. Okay, MA is equal to, we are going to multiply both sides by 5 to get rid of the 5 down here. So we have 24 times 5 over 20. 24 times 5 will give us 120 divided by 20. Now 120 divided by 20 is equal to 6. So that means that side MA is equal to 6 centimeters. And that's how you solve for it if you have a bigger triangle within a smaller triangle. That's all for now about how to show your work using similar triangles. Oh, one last little thing I want to tell you. Sometimes when you're doing these problems, they're going to use a different naming method. And that other naming method is that if we have this triangle here, triangle STH, the side opposite the letter is also called that letter side. So for example, because we have angle H here, that means this is side H. Because we have angle T here, this is side T. Because we have angle S here, that means this is side S. So when you're looking at triangles, you might see them named that way. Okay, that's all for now. I hope you learned something about similar triangles, and I'll talk to you later.